All right, we've conquered our remembering of how to work with decimals. Okay. Any decimal that repeats or terminates comes from some sort of fraction. All right, that's what rational numbers are. That's what we've been working with. So, yesterday you did some review with that. So, today we've got to take care of remembering how to do fraction multiplication. And then we're also adding in there these signed numbers, positives and negatives, putting it all together. So here we go. All right. Yesterday, I had you do a problem like this, -5 times +7. We remembered the rules. Oh, negative times positive. The first thing I want you to do is just, what's the sign of your product? There we go. Then come off to the side and simply multiply your two absolute values together. You've already determined the sign, so multiply them, and you get 35, -35. Cool. All right, and yesterday we delved into decimal numbers. Now we've got to talk about what happens when we have fractions, okay? Now I know you just many of you have some sort of thing about fractions, and I'm here to tell you fractions are our friends, especially with multiplication, because you don't have to have a common denominator. All you've got to do is just think of it as one giant fraction altogether, and you're going to take the numerators and the denominators and get your product straight across the top, straight across the bottom. Now, I did say my answer was going to be negative, but I've got to do some work here. So I'm going to come way off to my final answer off to the right. I'm just going to focus on the absolute values right now, the 5/14ths and the 7/10ths. If I went straight across the top, I'd get 35. Straight across the bottom is 140. And then we'd have to start chipping away at this and ask ourselves, well, what can I take out of here? You'd say, oh, maybe I could factor a 5 out of here. And so when I think about that, then I can start simplifying the fraction and work your way back into simplest form. But if you happen to notice that once you have all multiplication taking place in the numerator and denominator, you can simplify before you even multiply. Remember doing this? 5 and 10 share a factor of 5 because 10 is 5 times 2. So if I take the numerator and the denominator and factor or divide out that 5/5, I'm left now with a 1 and a 2. The same thing happens with the 7s, and I end up with 1 times 1 on top and 2 times 2 on the bottom, which is 1/4, and it has to be negative. Boom. Now, if you prefer multiplying everything out and then simplifying, absolutely go ahead. I'm just saying you might not recognize that 35 can fit into 144 times. You might look at this and say, ooh, well, I know I can see a 7 in each of those. And when I take 7 divided by 7, it's 1. So I'd get 5/20 and then work your way to the 1/4. Okay? You do it however you need to. I'm just saying I think it's easier to divide out your common factors and then you'll end up in simplest form. All right, now, sounds good. I got that. I remember how to do that. So what about when we start putting mixed numbers in here? Well, take these steps. 1, deal with the sign of your answer. Then you don't have to worry about it anymore. You just take the absolute values and go to town. Turn everything into a fraction. So any mixed number you have, turn it into an improper fraction. Then you can multiply, simplify if you can, get your final answer in simplest form. Okay? So the key here is deal with the sign, get everything into fraction form. So that means if you've got to turn things into improper, go to town. And here we go. So let's take a look at this guy. 4 1/3 times -2 1/4. The first thing I'm going to tell you is, what's my sign? They're different, so let's make them negative. Next, I'm going to say, whoa, whoa, whoa. Turn this into a mixed number. 4 whole pizzas and 1/3 of another one you're basically saying that's the same as 13 thirds. 4 times 3 plus 1. 4 whole pizzas, 3, 3, 3, 3, and 1 more slice. This one, 2 1/4 becomes 2 times 4 is 8, 9/4. Okay? And let's see what happens from here. Oh, actually, I was going to make these numbers work out a little better, but this is all right. This is all right. Now, I didn't put the negative sign here because I am in my head taking the absolute value of this. I took care of my sign of my answer already. So I'm really just wanting you to focus on the number values. Okay. Now, this is like one giant fraction. You just have to multiply numerators and denominators. However, I don't really want to multiply 13 times 9 if I don't have to. If there's some sort of factor in the numerator, that will divide with a factor in the denominator. And sure enough, 9 is really 3 times 3. If you want, you could just rewrite 9 as 3 times 3, and then you'll see 3 in the numerator with the 3 in the denominator divide out to be 1. Ta-da! That's a 1. So now I have 13 times 3, way better. That's 39. In the denominator, 1 times 4 is 4. Okay? When I put my final answer up here, I've got my negative sign there, so I've got it taken care of. In algebra, we often leave our answers as an improper fraction. We've trained you really well to turn this thing back into a mixed number. Say, 4 can fit into 39. 9 times, that's 36. I'd have a remainder of 3. Okay? I am totally fine with you leaving your answer as an improper. Okay? Unless it specifically tells you you have to change it. But make sure you have that negative sign. Okay? All right, I want you to open up your book because yesterday we just kind of cherry picked which problems we were going to do and we avoided the fraction ones and focused on decimals. Okay, now we're going to focus on the fraction ones. And by the way, rational number is any number that can be written as a fraction, some value A over some value B, where each of those are integers. Okay, so A is an integer, B is an integer. Remember what your integers are? It's all the whole numbers, 0, 1, 2, 3. But it's also their opposites, -1, -2. Boop, 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 boop. There you go. All right, so as long as these two are integers, and one last thing. It's totally against math law to put a 0 in the denominator. So B can't be equal to 0. Could be any other integer, though. That's what rational means. When we write them as a fraction, they're good to go. You can also write them as a decimal, and as decimals, they always terminate or repeat. All right, so I think this is good old page 83 again. All right, and what you'll notice is this example here. Example number 1 is one that's written with fractions and whole numbers, actually, in this case. And I want you to specifically look at this guy, okay? Now, they're modeling 4 times -1/2. So you could go -1/2, -1/2, -1, and do that 4 times. But I want you to see, how would I write this if I were doing the straight up multiplication without using a number line? The whole number 4, write it as an improper fraction. Okay, 4 times -1/2, I know is going to equal a negative. All right, you take your pencil and write that right here. But up above the picture, let's do this. Write it as 4 over 1 times 1 over 2. I'm not including the negative sign because I've already taken that into consideration. Multiply. This means you're going to take 4 times 1 in the numerator and 1 times 2 in the denominator. Hey, each of these guys has a factor of 2, and when I divide in the bottom, I get a 1, and up here I get a 2. 2 times 1 is 2 in the numerator. 1 times 1 is 1 in the denominator. Hey, that's plain old 2. Boom. Look at that. Same answer. Okay? What we're hoping to do is let you use the number line to visualize things, and eventually you'll be able to do it without the use of that tool. Okay? All right, all my stars, what if you have 3 of them all together? Well, here's what you're going to do. Okay? I have a negative times a negative. Those two, the negative times the negative, those two would make a positive value. And then you have another negative over here. Your final answer is going to have a negative sign. Okay? So up here, put a negative sign. Now, we don't need a common denominator when you're multiplying all of these together. All right? Rather than kind of how they did 2 at a time, I'd frankly take 2/3, 1/2, and make one giant fraction. 2/3, 1/2, 3/5. Notice I'm not including the sign. I've already taken into consideration the sign of your answer. I'm simply focusing on all the absolute values now and going to town. All right, if you want, 2 times 1 times 3 is 6. 3 times 2 is 6. 6 times 5 is 30. And then get this guy in simplest form. Or a 2 in the numerator can divide the 2 in the denominator and give you 1. 3 in the numerator and 3 in the denominator divide out to be 1. In simplest form, this is 1/5. Sweet. I come over here. I know my sign has to be negative. Sure enough, there you go. All right. Jump ahead, please, to this page. And I want to do some of these first ones together, okay? So look at number 1, 5 times negative 2/3, okay? The first thing I want you to do is say, over here, my final answer is going to be negative, okay? Positive times negative. 5 is written as 5/1 times 2/3. When you multiply fractions, you can make one giant fraction and multiply your numerators and denominators. I see no common factors. I get 10/3. You can leave it that way or rewrite it as the mixed number 3 1/3. Psst, you're not done though. Remember when I said my final answer is negative? So I would write it this way, negative 10/3, or if you prefer writing it as negative 3 1/3. There you go. Okay? Take a look at number 2. This means positive times negative. At the very end, negative answer. Okay? Ignore this part. Take 3/1, turn it improper, times just the value of negative 1/4. The absolute value is positive. Make one giant fraction. 3 times 1 is 3. 1 times 4 is 4. My final answer needs to be negative. Don't forget that part, okay? Cool. So here's what I want you to do. Your assignment will be a worksheet today, and you'll have a lot of room to write. Determine the sign. Any mixed number or whole number has to be written as improper. Go ahead and multiply, simplify. If there's any simplification or factoring you can do, get your final answer. Good luck, and may the force be with you.